In this video, we're just going to do kind of a comparison of basically the four types of inheritance that we've talked about so far, and look at how they're compared. So we have regular, dominant, and recessive, sex-linked, so remember that's on the X chromosome, incomplete, which was mixing or in between, and codominance, which was they both show up. So let's look at how we write these. Alright, for regular, I'm going to have a big R, big R. For sex-linked, I still have those big R, but again, because there's a difference between males and females, because that Y chromosome doesn't have a gene, a male would just be X big R, Y. Incomplete, I write that the same way, and codominance, again, I write that the same way. Now, the heterozygous for regular, big R, little r, only females can be heterozygous for sex lengths because, again, a male does not have that second X to have a letter on it. In incomplete, we're going to end up in the heterozygous having those primes. And in codominance, we're going to have a completely separate letter. And so in regular, I would have the recessive, homozygous recessive, be little r. Sex-linked, it works the same way, except, again, we have that difference between males and females. Incomplete, nothing is really recessive. It's just that the other allele would be R prime, R prime. And in codominance, the other allele would be the other letter, so like big W, big W. Alright, so those are the genotypes that I can get for those different types of inheritance. So let's look at what the phenotypes look like. So in every one of these cases, if red is my one allele and white is my other allele, this would give a red flower, this would give a red flower, red flower, red flower. And then at the bottom, white flower, white flower, white flower, white flower. The big difference is what happens when they're heterozygous. So in regular dominant recessive, if red's dominant to white, then all I need is that one big R and it's a red flower. Same thing with the sex-linked. It's still one big R, one little r, it's going to be red. Now with incomplete, it's a little bit different because neither one of them is fully dominant. And so since we mix them together, red plus white equals pink. And with codominant, since they're both dominant and they both show up, red plus white equals red and white that show up completely separate from each other. So let's look at a Punnett square for each one of these. So regular, there's my red flower and a white flower. So I have a heterozygous and a homozygous recessive. I set it up, and I'm going to end up with 50% heterozygous and 50% homozygous recessive. For genotypes. For phenotypes, 50% red, 50% white. So let's say I do the same thing with sex-linked. So here's a male, that's a red male, and a white female. I set them up the same way. 50% heterozygous females and 50% recessive males. So I would end up with red females and white males. Incomplete dominance, let's say I have a red flower and a white flower. Set it up the same way. All the genotypes of the offspring are the same. And big R, R prime, all the offspring would be pink. And then finally for codominance, here's my red flower, here's my white flower. Set up the Punnett square exactly the same way. Again, all the offspring are going to be exactly the same. They're going to be big R, big W. But instead of red, white, or pink, they're going to be red and white together. And that is just a basic comparison of how Genotypes and phenotypes work with the 4 types of dominant inheritance patterns that we've talked about in this unit.